Hey guys, thank you so much for joining this month's session. And this month we have two tech talks. And let me show you. This is .NET Learners House, Hyderabad. And here in this month, you can see two topics. The first topic is on the semantic kernel and Azure OpenAI and Hugging Face. And the second topic is on deploying containerized apps with container registry and app services. Okay, so there are two topics. Let me bring in the another speaker, Rashmi, and I. We are going to talk about these 2 points. Rashmi is from London. Rashmi, do you want to introduce yourself?
Oh, yeah, sure. So as you hear, I'm joining from London. I'm a software professional with over 16 years of international experience. I began my career in embedded systems, building and debugging low-level software. And over the years, I have transitioned into Python programming, some backend development, CI/CD technologies like Docker, Kubernetes, and Jenkins, and now more into the AI space. So I'll talk about myself a little later, and I'll hand over the stage to Swamy to carry on with his presentation now. Thank you.
Thanks, Rashmi. Thanks for joining from London. So you'll be on the backstage. Let me share my screen, and I will go. Thanks, guys. So this is my GitHub repo. Let me post it here so you can have this handy. So I'm posting it here, and you can see that all the markdowns will be here. I was a little lazy. I did not do the documentation. Like if you see that there was one event yesterday, so I had to spend a lot of time in bringing this documentation in yesterday's event. So I went a little lazy. So this documentation is not available, but I'll get this up and running in a day or two. And the source code for today's session is in this organization where I'm trying to consolidate all the projects which are related to AI, ML, and data science space. So all these things will be here under this organization. You can follow, and let me paste it here. So today we are going to discuss on this topic. It's a broader one, but let me paste this organization. If you want to follow, please go ahead and follow that. And that's it. So let's start uh, today's topic. So we'll see that what is that we are going to do today, and a little bit of the background, and we'll see something else. Okay, so let's see what is this OpenAI research. By the way, I'm using this chart agent, GitHub chart agent, to prepare the documentation. It's pretty handy. So let's speak about this for a minute, and before we are going deep into the weeds. Okay, I just want to show you a couple of other projects. So just to set the context. So let me open this as one project, and let me open this in another project. The first project is, let's set the context. You know, Open AI. Let's set that. The first project, OpenAI chart and Flask. So I opened the wrong window. Just give me a minute. So the first project is, let me open the folder from here. Let's go to the D drive, AIML, and OpenAI chart Flask. This is the folder. Let me open this, and from here we'll go. So let's set up some context, hands-on demo, less of a slides and more of a code. So we'll spend a little bit time over here. Like, what is OpenAI? OpenAI, that's a AI research and development company, and they develop a lot of models, and we are using those models day in and day out. And some of the things are generating content like human or better than us, making our lives faster. Sometimes it might give a different answer. We should have that much of knowledge on the technology what we are working. If OpenAI gives a responses which is not matching our expectations, or it's giving something different, we should be in a capability to understand what it is giving and how do we want to fine tune. Now everything depends upon the prompt engineering, saying that, hey, I want this, asking it to modify. So that's about the OpenAI. So what we will do is, first we'll spend couple of minutes on this, and then we'll go to the Azure OpenAI, and we'll spend some time on Hugging Face, and then we'll see the consolidation of that. Okay, let me quickly go, copy this path. I'm just practicing some algorithms. So my algorithms is failing. So let me see that I have the virtual environment. I'm starting the virtual environment, and Pi app. I'm starting this. Let's see how are we interacting with that. Now, if you see that there's one something secret, and apart from that, Open AI API key that we will have to generate from the OpenAI uh, OpenAI website. You need to have some dollars to get that. So I just want to show you quickly the platform that Azure OpenAI. So I bought very least $5, and I'm able to do a lot of experiments. If you see that the total number of requests are this much, and it is pretty cheap. Also, I really liked this one, so I want to explore more. So here under the API keys, you'll have the keys. Even I can show that it doesn't expose my key. So this is a key which I created on Jan 23rd. I'm still experimenting, and the billing usage is less than, I don't know, 0.08 or something. Still, I have out of $5, I do have a lot of this thing now, and that's about that. So I stored it in an environment variable. Now you see this Flask API. This is just a single baby step to show that how do we interact with OpenAI. So that's OpenAI key, and here we have a chat message. So whatever we send it as part of the user interface. So user interface will look like this. Okay, let me directly show you the user interface. Then we will speak about it for 5 minutes, and then we'll come back and we'll do another look at another project, and then so this is the one. This just it's a first baby step, and there are a lot of things which we have to integrate with this. First, porting this to Django from Flask. That's the first task. So we can come to this one and ask, what is your name, and enter. So you can see that it goes and talks to the OpenAI, and it brings that I'm just a language model. So I can say that write a small poem in Spanish and convert it into Japanese. Okay, I'm giving the instruction. I don't know both the languages, but I'm asking it to do. That's a fun part. So now we'll see the same one, and we'll ask that Japanese and English. We'll say that Japanese and in. We're asking it to write one small poem, and okay, in the garden roses bloom. Okay, whatever the Spanish poem has been translated to Japanese. into English. Now, this I just wanted to set the context, like what is OpenAI? It's a it's a company, and it generates the first part. It has generated a lot of models and GPT transformers, and it has got a lot of capabilities. And we are using Azure OpenAI and the model. What is that model which we are using it? Let's see that. Uh, Let me go to this chart interface. The model is here, GPT 3.5 Turbo, which is a little cheaper. And now I can come back here and go to the billing space, usage space, and you saw that we did few requests, and we know that 13th April we did. It was almost like this, and it pumped it like, okay, we might come back and do some other things later. So now at least we know that how are we interacting with chat OpenAI. As I was mentioning, all the code is inside this organization. Okay, Swamy's Tech Skills Academy, AI, ML, and Data Science. So here, the project is OpenAI Flask, Chat Flask. That's one. So let's spend some time on how do we interact with Azure OpenAI. So let me go and open another instance of VS Code, and I'll keep this interface. Go and I hope I'm not using port 5000. I assume. Let's see that. And let me go and open another project. Again, I have to go to D colon and the data science. Okay, here there is another project, Flask React, and Azure OpenAI. So this is again another project. How do we interact with Azure OpenAI? Okay, so let's set the context for a minute and again come back over here. We can see what is Azure OpenAI. So Azure OpenAI is a service provided by Microsoft. It did a lot of investment in OpenAI, and I think Microsoft Azure is the only cloud provider who gives exclusive access to OpenAI capabilities with scalability, security, and compliance feature. The good thing is, like, if we use Azure, so these things are coming like a built-in, like scalability and security and compliance. I mean, I'm not giving a blanket statement, but to a decent extent, it provides everything. But something we need additional, we can go speak to Microsoft and take their helping hand to extend those things. So that's about the Open Azure OpenAI. So we saw how do we interact, and now we'll speak how do we interact with OpenAI. Azure OpenAI. Is we have a front end. So let me take this, copy this backend, and again we see that we have the OpenAI. What is the model we are using? 35 GPT 35 Turbo, and also um, we are using the Blueprint, and here it is purely the API, and this side it is. If you see, we are working on the React, and again it is React 19. And let's see, do we have .venv as a virtual environment script and activate and by app. So I've started this. I've started this, and let me come back to this one. And I have to be here in the backend itself. What we can do is So we need the Azure OpenAI key. As I was mentioning, I just stored it in the environment variables, and we can use the Python requests to test our endpoint before even we create the user interface. We can use this to go ahead and wow, that's cool. So make sure provide a valid key for an active subscription. Correct regional. Did I remove that? Just a moment. Did I do? I just tested it. Let me come back over here. Where are we? Here. Let me go into the API. There's a chart completions API, and am I fetching it over here? Where am I fetching it? That's the Flask, and that is a service where I'm fetching it. Azure OpenAI key. Did I call it V1 like this? I don't remember. Should be one out of that. I might see that. I changed the key in my environment variable, but I forgot to update this code. So now we are seeing that we have built a small backend, and we are using PowerShell. We can use curl, Postman, or any of those tools to validate it. Now that we are confirmed, like, oh, okay, we have exposed an endpoint using Flask, and it's talking or communicating with the Azure OpenAI. And to validate that, we used PowerShell invoke REST method to get the data. We are able to satisfy to a decent extent. Okay, we can try what is an apple, and then boom, we are getting a response. Okay. Oh god. Okay, we'll say that I'm not asking, oh, apple one. That's my mistake. Does it give a different answer? Apple is a fruit. Okay, so it was my mistake that I typed apple one, but orange. It speaks about orange fruit, and it speaks about this. Now we are interacting with Azure OpenAI. That means it goes to into the Azure space, and internally, how does it communicate? I'm not sure, but some security is there. It's clean now. Let's come back to this one, and let me go to the front end, and I'll click on this copy path and come back to this terminal where I will paste it. And let's see, npm star run dev. Okay, so where does that comes? If you go to the package JSON in this, we will see npm run dev. We don't have the start. Technically, we could have used instead of dev, we could have used that itself start, and it could have started it. But whatever it is, we have this. I'll click on it, and this is an interface. We are seeing this is all singleton. That means I post a query, it gives me an answer. It's done and tested. It doesn't have any memory. As I was telling, this is the first baby step towards the development of that apps. There'll be rest of the year. We'll be focusing more on AI apps. Please keep a watch on this. There'll be a lot of projects which will be coming in here rest of the year and maybe next year. Let's see that. It's loading. It's taking some time. It will definitely take. See that it takes 1 or 2 minutes, not too much of time. But let's come back to this, and let's go to the network tab just to ensure that all is well. Okay, let me empty cache, hard reload. Okay, it's pending. Let's keep a watch on this. Is it compiling? Sometimes it takes time. Ooh, there you go. All is well. These are just for aesthetic look and feel. It doesn't work. Okay, whether it is login or log out, does nothing works. As I was mentioning, this is the first baby step towards developing some practical apps, like, you know in a company. Let's assume that there are two departments, and there are five people in these two departments. So instead of handing over the keys to those team members or to those departments, one of the way to do is centralize or create an application and host it and uh, hook it up to the Entra authentication, so all the people who belongs to that department can access this application. And the billing will also be centralized, like one instance and two departments. So we know that what is getting consumed. On top of that, we have to store who is hitting how many times and what kind of queries they are passing in, what kind of responses. As we see that in chat gpt, it tracks like what queries we posted yesterday, what queries we are doing it today. So let's see that here it is a little different. What is an apple? And then I'll hit, it says thinking, and it gave that. Okay, so I'll come and write a small program to find Fib- Fibonacci in Python. So it's thinking, and then all of a sudden it gives an answer here. This is the Python program to find a Fibonacci series, and it gives us much more information than what we ask. So now we spend some time to understand what is OpenAI, what is Azure OpenAI. We'll see Hugging Face. Now we come to this Hugging Face, and inside this Hugging Face there are a lot of models which you can use it for free, and some of the models which you have to spend some money or register it here. I can type hi, and it goes, and I think this model is not available. We can view the code also here, but what we have to do is, whatever we are trying to do is text generation. We can select this text generation, and we need to spend some time to understand like what models are available, and which one we can use it, and which are working and which are not working. It's like we can try this instruct, this one, Mistral 7B instruct, and see here it says that agree to access this repository. Some of the models is, if you type, it's giving the response. How are you doing today? Now it says that, I'm doing well, thank you. How can I help you? Like these models we need to understand. Now, and again, it's from the programming perspective. I didn't do any code here, but even if you see that, whether it is curl or JavaScript, you can have this, or doing in Python, you'll have this sending it to a request, or how do you interact with OpenAI. All these things are there. Now we saw three different things. We saw OpenAI, Azure OpenAI, and Hugging Face is leading open source platform for NLP, and they have these models. Now we need to select that what models are free and what is the limit, and what models cost us. Now is that we are interacting with multiple models from multiple sources. Now, where does semantic kernel come, and how are we stitching all these things? Like semantic kernel is an open source framework designed to integrate AI models. Okay. Now we saw that we are interacting with three different things, and how do we stitch it is very important here. So it provides an unified interface to interact with these models. So we can build these intelligent applications. Like if you see how are we interacting when I come in here, how are we interacting when we are using the OpenAI. So you see this, that is having a different, it could be a different uh, library, or it could be the same library, it could be different parameters, same parameters, or a slight variation of the parameters, it could be anything. But we'll see that this is OpenAI. It does, you have to interact in this way. Now when it comes to the Azure OpenAI, let's go to the service and see that what is that, how are we creating. We created here, if you see that we are they're asking the model name, and the key has been given over here. This is the key which we are injecting. Takes the key and accept the model name, and done and dusted. OpenAI goes and hits the model and generates the response. But when it comes to the Azure OpenAI, we are seeing that first we have to create a client. How are we creating a client here? Is we're creating OpenAI and just pass the API key. Now it believes that, oh, give me the API key, you're good and good. Okay. Now when it comes the creation of this is you need to pass the key, endpoint, and the API version. Three different things. And how do you interact here? If you see that it has got chart completions, create. All it needs is a model name. Okay, and whereas here it's a model deployment name. It's pretty different. So you can give anything, simple or jack uh, deploy or something. So different things will be there. If you see the deployment name, I used GPT-35 Turbo 16K DName. I always add DName because in OpenAI, if you use this, that's enough. Here you can see that it just need a model name, 3.5 Turbo, or if I'm using 3.5 Turbo 16K, I can give this. But in Azure, the interface is little different. How do we interact? So while you create an object or while you interact and getting the response, there are subtle differences between different companies or different models. How do you interact? Now where does this semantic kernel come into picture? Is that it's an open source framework. Now if you give uh, information about a model which we want to use it, whether be it OpenAI or be it Azure OpenAI or a Hugging Face, it goes and talks to it. But you don't need to know the internals of how it is happening. Now we saw that little differences between these two, between on OpenAI and Azure OpenAI. See how the client is getting created and what kind of parameters you're passing. But net you're eating the same thing. So let's come back and see that client here also client, and the next thing is chart, because it's the same library, isn't it? It's a chart, and here completions, and here completions, and you say create and create. Little bit difference, but rest of the things are pretty much the same, because end of the day we are using the same library, OpenAI, and inside that, what is that you're using it? It's little uh, a small difference, but rest everything should be same. Let's see that. Where is the OpenAI here? 1.67, and when we come to this one, Azure OpenAI, and 1.68. Okay, plus or minus zero point 0.1. Right. Now, when it comes to the solution here, is that let's just divide it, this. Let's see how it is getting divided, and how is the entire things are getting stitched. So nowadays tools are very powerful. So let's use the tools to get our job done. That will be pretty much easy. So it's generating the diagram instead of I putting it the diagram. So we know that here we have this is the, let me expand those. Let me open that. And so you know that at a high level or at a low level, what is happening. Okay, come on, I created this. So this is the host builder factory, which is there inside this infrastructure, where we are creating the builder and adding the app settings and user secrets. And apart from that, we are adding the environment provider, the singleton to get the configuration, and the environment provider, and the semantic kernel config. And we have used three wrappers for the kernel. And I have to show you one picture. This is the basic application, semantic kernel. Let's go to the documentation. And it's just we are touching the tip of the iceberg, nothing more than that. So if you see that, there's one good image. I just want to talk about this concept over here. The kernel. This is the first one which we are touching it here. The kernel is at the core. There are a lot of moving pieces. We'll definitely come back, and rest of the year, as I was mentioning, we'll focus on semantic kernel and a lot of other AI and those things. But if you see that this is the kernel, so the application gives it. We didn't touch all the things are defaulted. The kernel goes and talks to any of these models. We are using all three models. So if you see here, the one wrapper is for OpenAI, and there's another wrapper for Azure OpenAI, and another wrapper for Hugging Face. So give a prompt, it goes through this pipeline and hits all these three models, get the response, parses it, and sending it. Now we are not knowing the underlying how it is speaking, but it's making our life easy. As we saw, there are slight differences between how do we interact with OpenAI, or how do you interact with Azure OpenAI or Hugging Face. It's a different interface. Now the semantic kernel is taking the responsibility. We say that, hey, I want to talk to this particular model, which belongs to either OpenAI or different companies, or where the model comes. Just give the parameters, whatever it needs it, and it goes and hits that. So let's see this. We saw the infrastructure, and we need to speak about the kernel for a minute. Let's speak about the configuration. So let's come back to this configuration. So here you can see semantic kernel config. Like, we are hitting all three. So Hugging Face, Azure OpenAI, and OpenAI, all these three. So whatever is needed. So here we are deciding whether we want to read it from app settings or secrets.json, or from the OS. So sometimes some of the sensitive things, it we want to use it from the OS. Now, if you see here, I did three samples. Somewhere I went and modified that. You can see that Azure Open API key. Now you see this Azure Open API key. So if that is working, if this might not. So I just created two different samples I was working. So these things also getting read from the same environment variable. Okay, and these are the wrappers here. So how do you create this is Azure OpenAI, and this wrapper, it's just I'm calling the same kernel.create builder, nothing new. Only thing is wrapped it in a separate class, so that I know that it will be easy. If I want to change, I can change. I can put it all these three lines within the same program.cs, but maintainability will be a little hard. If I want to change either any one of uh, these interactions, I need to go and change the program.cs. I just want to keep little neat, so I just moved it, nothing big. So we'll see how it executes, and then we'll speak about the closing thoughts. We'll speak about the. Let's wait. We'll see a couple of prompts. It's taking a longer time. Is it bombing on us? No, it is. Okay, see that. Uh, OpenAI, Azure OpenAI, and Hugging Face. Let's ask the same question. What is your name? So it's going. There will be two things. Now this is streaming. Now again, this is full length content, and this is streaming. And this is full length content from Hugging Face, and again, it's a streaming. So we gave a prompt, and we tried two different things. One is synchronous call. One is streaming. I mean, sorry. One is it waits until it gets a response. It flushes it on the output, and the other one is streaming. As and when we are getting chunks of data, it prints it. You see this. I'm called assistant. How can I help you today? If you see from OpenAI, both the responses are same. And if you see the Azure OpenAI and the streaming in Azure OpenAI, it's little difference. I'm your helpful assistant. You can call me assistant, and that gives a little difference because the temperature is little higher. That means little randomness or creativity. And here also we can see that Hugging Face, we're getting two different responses. Now we saw how do we interact with OpenAI, Azure OpenAI, and Hugging Face. We directly interacted with the model using their portal, but uh, generally uh, it will be done with the coding. I didn't do it, so I just showed it directly on the portal. And then we introduced semantic kernel, which, if you see that, the unified interface. If I come into the service, you see that prompt service. What is that it is doing? It's doing the same thing. Like we are creating the eye chart completion, and inside the eye chart completion, we are calling get message content async. That's the Azure OpenAI, and this is a Hugging Face. You don't see any difference. We get the same chart completion, but you're getting it from the different wrapper, kernel wrapper, and rest the interface is same. How he is dealing with that internally is a different ball game, but you see that from here it is the same. I can pass a general. If I come into this wrapper over here, and I could have taken this kernel as a parameter and pass whether the OpenAI kernel wrapper or something, get the builder what it needs. End of the day, this guy is creating the kernel. So I can take kernel as a parameter and pass any of these wrappers and then call the chart completion, reducing those two, three lines also into much smaller. Okay. So that's about my session. Hope you have enjoyed and learned something new. And let me bring in Rashmi. Hey, Rashmi.
Hey, hi Swamy. That was a wonderful session. I got to
Thanks.
learn something new, semantic kernel. Is this something very similar to agentic framework that Azure is
Well,
offering?
yes, it's very similar. Like you see the autogen and other things are there, LangChain,
Mm.
like that. These are coming in the same one, but this is pretty powerful. I just explored last month. I was doing some experiments, and there are more to explore. So planning to do rest of the year on that. Cool. So, all
Fantastic.
right.
Yeah.
Thanks. Do you want to share your screen? Let's get.
Yes. Yeah, let's go ahead with my session. So first of all, for all the late joiners, good evening, everyone. I hope you're all doing well. Thank you for joining this session. As you may notice or heard before, I'm joining in from UK, and I really appreciate you. taking time out of your Sunday evening to join this virtual meetup. Uh, really much appreciated. I'm looking forward to share some technical insights and have a great exchange of ideas. So what I'm going to share today is, say, for example, you use a semantic kernel and build a fantastic app, and you want to showcase it to your friends and colleagues. So you will not be able to share your web server that you launch in your local laptop. Instead, you need to host it on the cloud, and then you can showcase your work to the outside world. And that is the part we're going to look at it in today's session. So before we dive into the technical things, a short introduction of me, because I'm giving this session for the first time. um, I have I have an experience of 16 years. My experience spans from embedded systems to backend development to CI/CD, and like Swamy and many of you, I'm also exploring into the AI space, and I enjoy learning and adapting to new technologies. And that's how I make my work quite exciting and impactful. I'm very curious to explore how these new technologies can solve real world problems in a smart and meaningful way. And I want to I want to state one more thing is I know your time is precious, our time is precious, and since this session is limited to just about 30 minutes, I may not be able to go into the micro details of every topic. So the goal today is to stay on a fast track. So what we do is I'll introduce my app, we'll run my app locally, and then host it on the cloud using container registry and app service. And finally, we'll look at how we can automate this workflow. So I will pause briefly after each topic just to check if there are any questions. So I may not have explored every single feature of these services. So if there's something I don't have an immediate answer to, I'll make note of it and get back to you later with my findings. So without further ado, let's jump straight into my GitHub repository. So let me go ahead and present my screen. Um, yeah. So are you able to see my screen as for me? We had some issues just a while ago. Yeah, I think.
Yeah, it is clear. I'll go on a backstage.
Mhm.
Floor is all yours.
Yeah, thank you. Yes. So this is the repository. So I'll share the repository link. Okay, I have some trouble posting the link, but I'll have Swami help me share it later. So we'll get through the sessions for now. So this is a simple app. So what do we need to know to make the most out of this session? So if you're aware of some concepts around the containerization, why we containerize our apps and how it makes our life easier, it'll become bit better for you to understand these technical concepts. And I'm sure many of you or all of you know some or other form of programming language. And if you have dealt with the Azure portal in some way and access the Azure command line interfaces, and if you understand what are these resource groups, that will also help you a lot. And some basic understanding of what is a workflow that I refer in my these talk will also help you if you know continuous integration and continuous deployment. And first of all, if you don't have a GitHub account, that is my first suggestion. Please go ahead and create your GitHub account. And that will let you explore a lot of features that the Microsoft is offering you. So how can we run this workspace? There are three different ways we can run our workspace. The first one is, if you're aware of, you can run a code space right from this link. That will open up your VS Code IDE in the browser, and that lets you do everything that's possible with this repository and whatever I'm going to share today. And how this code space works is based on the dev container, and this dev container JSON will dictate the commands that's required to containerize this app and run it in the code space. And if you wish to use this dev container JSON to launch your workspace in your local VS Code instance, then go ahead and install a dev container extension. So I have provided links to each and every topic that I'll be touching on the surface, and this will help you to establish your understanding more about these new tools. So let me show you, I have this in my extension, dev container extension. And when you open your folder, when you open your directory or project directory in VS Code, it'll prompt you if you're interested in opening using a dev container, if it identifies a dev container JSON file. If it is not available, then you can go and use reopen in a container option from the command, and that will help you load your workspace. So for today, we will approach a little primitive method, which is by creating a virtual environment. So by the way, just to highlight, I have also enabled the linters for my project folder. So what are linters? These are all the tools that will help you write a better code, a formatted code, and that'll help you identify some bad styles and some subtle mistakes. So if you run your code through the linters before push your code to the review stage, the reviewers will have a pleasant time to approve your code, and you will be able to merge your code to the production. So Python virtual environment, I'm sure you're aware of the virtual environment that will help you isolate your code and dependencies so that you're very well aware of what is required as a dependency to run your application. So the way you create your virtual environment is by running this command. And just in case you're looking for further information on the virtual environment, you can refer to this link. This will help you understand what is a virtual environment, uh, Python environment, and the possibilities that it brings and the flexibilities that brings to your coding experience. So these are the ways that you can activate your virtual environment. And for the project configuration, I have used PyProject TOML. This is the setup tools. This is an alternative to requirements.txt. So this is also the first time I'm using it. So I feel this is a convenient way where you can mention all your dependencies and do the tool configuration also, including you can set up your metadata for your packages. Let me just quickly open the PyProject TOML, and this is the contents of the PyProject TOML. As you see, we have the metadata for the packages, and these are the dependencies that's used in the production environment, and these are the additional dependencies we may need in the development environment. And I have done my linter configurations also using the same project configuration file. Okay, so let me close these windows. Okay, so pre-commit hooks is another feature that will help you a better development experience. So let's open the link. So pre-commit hooks lets you run some of these linter tools when you commit your code locally. So in this way, you can capture your style issues, formatting issues much early in your development. So, and I just want to show you one more thing. These pre-commit install is also enabled in your dev container JSON. If you go the post create command will install the development requirement dependencies followed by your pre-commit install to enable your pre-commit hooks. Fantastic. Okay, so let me open my VS Code. And as you see here, I have already created my virtual environment and I have activated it. And that is where we are in this state. And the simple app that I have built to demonstrate this deployment is in the source folder, and some home HTML and results HTML. I've kept it quite simple, focusing on the deployment aspects for this particular session. So let's go ahead and run the app. I'll launch my app. And this is the app that will help you run a search over the GitHub. So maybe neural network. I'll go and search for this keyword, and it came up with so many repositories. These are the names and the links and what is the summary. In fact, I wanted to extend idea on how this app works and run it through the AI endpoints to summarize the entire repository. But for that is for another time. So this is how a simple app. Now we made sure that our code is running and it is able to do what it is intended to. And there's one additional point, as you may have seen, about the .env file importance that Swamy was explaining in his project. We have a similar thing where you have to mention the GitHub token, because this source code will connect to the GitHub using your token and establishes connection to do the search. Okay, so what we will do is we will stop the app running because we made sure there was no error in the code. Then now we will proceed to see Azure Container Registry.
Rashmi,
Yeah.
could you please do a control plus to increase the font size because it's pretty dark.
Oh, is it?
Um,
Okay.
yeah, I mean, just increase the zoom in.
Zoom in?
Okay, a
Okay.
little bit more. Uh, oh, okay. I think that
Okay.
should be good. Thanks. I'm going back on backstage.
Yeah. How about the font size or visibility on the VS Code?
VS Code, it's pretty small. I think you need to do the control plus plus a couple times.
Command plus won't work on the Mac.
Yeah, yes, Command plus in
I
Mac. I think yours is a Mac box.
Let me just go and change the font size instead. Probably. I will mostly need the terminal.
No, what I'm telling is you can increase the
Okay.
zoom in. You can go and try zoom in. In the
Okay.
search bar, you can try zoom.
So yeah, I'll go with that. Just a
Yeah, go
second.
with the zoom. Increase. You can find that.
Okay.
Okay, there you go. Here in view appearance, and then there you have zoom in and zoom out. In the view menu, appearance, zoom in and zoom out.
Okay, is this better? Is
Uh,
the term
Still a little bit more if you uh,
Mhm.
appearance. Yeah, there. Yeah, one more.
Mm,
Yep, this
okay.
much better. Thanks
This
so
is
much.
better. Yeah, yeah, no worries. Okay, so let's resume our session. So this is the Azure Container Registry. So what is Azure Container Registry? Is a managed private Docker registry service based on the open source Docker Registry 2.0. So it allows you to build and store your Docker images. So if you have seen the interfaces of Docker Hub, or if you have an experience with the Docker Hub or JFrog Artifactory, where you store your Docker images, and Azure Container Registry offers the same service, and that makes it much easier for you to deploy them in the Azure app services or container instances and other kind of hostings that's available on the Azure. So what do you mean by a managed service? Managed service refers to a cloud offering where Microsoft handles the operational aspects of the service for you, like provisioning, maintenance, scaling, updates, and security patches. Say, for example, if you were to host this on-prem, you may be securing resources required, installing the software that was necessary, and setting up the networking. There's so many tedious mechanisms that you may have to go through to host your app to let the world know what you're working on. So resorting to cloud provider services like Azure, Google Cloud, AWS makes life easier. I personally find Azure very interesting because the documentation that comes with Azure is so comprehensive, makes it easy for the first-time learners. So there are key features for this container registry. As you may see, geo-replication is also one of them, that let you make your images available across multiple regions. The download becomes faster, and you can scale up and scale down based on your requirements. Um, yes, so as I was saying, I may not get into all the details of it. I have provided further links for you to learn about the container registry. This is one stop from where you can learn about each and every feature. And there are some small modules that you can complete and acquire or obtain your certifications. And the second link is, yeah. So these have the screenshots that makes it much easier for you to understand the container registry. And one thing is the admin account. And this is one other thing I will be enabling. I will show you practically demo now in next few seconds. And we will enable this admin account, which allows your app services to log into the Docker in container registry and pull the images. So this makes the container registry name as a username, and there will be access keys that can be used as a password that establishes the communication between container registry and web app. This is also one interesting read for you when you explore this repository. So you have the container registry for deployment. So let's go ahead. You can go to compute. You can go to containers. You have a container registry. So I have created one resource group earlier to this session so that I can run you all through the GitHub actions, because it would take some time to create the credentials required and get the app running. So I have created one instance that's up and running that I will visit at the end of this session. For now, let's look at creating a new container registry. I will just move this window a bit to the side. Let's see. Okay, I see some comments, cannot see code. Okay, it's good now. Okay. So let's create a new resource group. What is a resource group? Here, the resource group is a bucket where I am I'm aggregating all other resources that's required for me to deploy my app. For example, um, for this application to be deployed on the cloud, we need container registry and app service, and those are the two you see inside this resource group. So when you're done with your job, if you just delete the resource group, it'll clear all the instances, and that will help you not to incur any extra charges that you might have forgotten to release those resources. So I will create a new resource here. So I'll give a name as RG for me too. Remember, I will just make note of these things so that I can spend less time revisiting these pages to know the name. So I'll use this as a resource group, and we will give a name to our registry. Let's use, I just pick some random name and I end it with CR as a container registry so that it's easy for me. And this is the name of our container registry. And I choose location as UK South so that my deployment is smooth and I can show um, the app running in a short duration. I will choose a standard. We will go to the next tab as in networking. For now, this is available for premier pricing plan. So I'll leave it with the default values. Encryption, and this is again for the premium plan. You can encrypt your image and store it in the Docker registry. Container registry. That's one of the options. So there may be additional charges for it. For now, I leave it empty. I don't need the tags. So basically come to review and create. And this is where the validation has passed and you have keyed in all the basic necessary values for you to create the container registry. So I'll go ahead and create my container registry. So basically, we are at the step where we have provisioned our container registry. It will take a while for the deployment. There you go. The deployment is succeeded. Go to the resource. Then if you go to the repository, there is no images at the moment. So as I was saying, admin user, we either can enable it now or enable it just before we provision the app services. So I'll go ahead and enable the admin user for this registry, which will help us to use the username as a login name and the access key, the password as the password to log into the container registry. And in this case, in this deployment and in this demo, app services will use these credentials to log into the container registry. So I can go to access keys, and here is where you find the admin user. This little information icon will help you understand what this is. Go ahead. It will take some time, and yes, it's enabled now. Cool. So our instance in Azure is created, which is the container registry instance. And the next steps are to build your app image and push into the container registry. So for that, you need to first log in to Azure from the command line, which I've already done it. I do not want to run this command now while I'm sharing my screen. That might compromise my uh, my Azure credentials. So I will jump straight into the second command, which is to log into the container registry. I'll go ahead, paste this command, and okay, ACR login and our container registry name. Here you go. Let's leave this here. Login is succeeded. You control the access with the identity. Okay, and container registry supports Windows and Linux images. So I am compiling. I'm building this image on my Mac machine. So hence I will use the build X command so that I generate AMD 64 compatible image that I can push it to the container registry. Otherwise, I'll have difficulty to run my app in app services. So I will take this command and let's Docker build X. So we need to mention the login server. And where do I find the login server? You come to your instance overview, and this is where you find your login server. Give my login server, and here's my image name. Let me use my image name as app. Okay, so and I will use the tag as latest for now. Okay, so the dot will tell the Docker command to go and find the Docker file that is there in the repository, which is containerizing your application. This is a very simple Docker file. It's using a base image as a Python 3.12, and it will copy your code and it will install the Python packages, dependencies, and then it will expose the port 8000, and this is the startup command. So I'll go, and there you go. So when I run Docker images, this is the image that we just built. This is the image that we have just built. Yes. Then what's our next step? Now the image is in your local machine, so you need to push the image to the container registry. So I will go ahead to Docker push and keep the image name. The first part of the image name, that is before this / will tell you the registry where it is supposed to push. And here is the image name with the tag as latest. There you go. Give it a while. Let's go and check on the next step. Yes. It's pushing all the layers. Bear with it. As in the last step in the documentation, you can actually run this image locally just to make sure there's no problem with the image and it's good to push to the registry. But I've already made sure this piece of code is working. So I will not be running the image locally again. Okay, so it has pushed, and let's go to the registry and check out in the repositories. There you go, your app is here. and its tag is latest. So now you built your web app, which is in the Azure Container Registry. So let's move to the next step, which is to provision app services. Provision your app services and then pull the image. So what is app service? App service is, again, it's a managed hosting for your web application. Azure provides so many different hosting mechanisms, as you may see here in this diagram. You can opt for virtual machine, and if you opt for this, you have to install all the softwares and configure them. You have to do everything end to end, or you can go with the Azure functions. And I have chosen app service because it's easier. It'll help you to deploy your code as well. But here I am opting for the container because for the Azure app service to host your Python code, you need to have a requirements.txt, but I'm using the PyProject TOML, so I decided to containerize my app. So depending on the level of control you want on your deployment, and the cost, then you can follow through this flowchart that puts you through this yes no blocks for you to help you decide what suits for your current use case. So this is given as a link. You can go and study further and get to know more about all the services that's offered in Azure. As app service is also a managed service that makes your life easier to showcase your cool AI apps that you may build with a semantic kernel, LangGraph, LangChain, small agent, can be anything. App service plan is another important terminology in the app service that lets you decide your cost. Depending on your app service plan, Azure will use the compute resources that eventually sums up to the cost that you pay. So now when we go to the practical demo, you can see the app service plan can also be created automatically for you during the deployment. And as I was saying, since this project does not have the requirements.txt and using the PyProject TOML, then we went through the step of containerizing our app before deploying. Okay, so there are links to further resources, including what the app service is, its introduction, what are the concepts, and how do you plug in the security aspects and credentials, everything. Yeah, have a read, have a look at these links. So let's go to provisioning an app service instance. I'll go here. I go to all services, or you can even search for app service as you see here. Just say app service. You can choose this. I'll create a web app. Go, and I will choose the same resource group under which I have provisioned my container registry. So my container registry that I am using for this demo starts with the DD. So I'll select this one, and I will select the instance name, this app service instance name. As this one, and this name is available. I'll just make note of it. And I will choose what I want to publish to this web app is a container. And what kind of container I have is a Linux container. And the region, my container registry, I chose UK South as a region, and I'll select the same for these two services to communicate better. And this was the pricing plan I was talking about. App service plan pricing tier determines the location, feature, cost, and compute resources associated with your app. So for now, for this deployment, it has created a default pricing plan for me, and pricing plan is basic, and I live with that, and that's enough for this simple application. So I'll go to the next tab. And this app don't require any database, so I will not select this one. I'll go to the container. So you can learn more about the sidecar containers, but I'm not using for this application. So I'll select the Azure Container Registry. And in the drop down, we'll select this as a container registry and the admin credentials. And this was the admin credentials I was talking about while provisioning our container registry, that where we enabled admin user on our container registry. So by enabling that, it makes the web app select those authentication credentials. So the image name is this one, and the tag is latest, and I don't need to give a startup command because my Docker file has a startup command already. I'll go to the next one. So I leave it for the public access and virtual network integration. Let's leave it off for now. This is the demo. And monitor and secure will cost you additional charges. So I'll just leave it as no, and the tags are not required. Let's move to review and create. There you go. The validation is complete. That is why I see a create button enabled. It's using the basic SKU, a small size, and just 1.75 GB. Go ahead and provision it. And bear with it, it'll take some time. Okay, it's done. I'll go to the resource. As you say, it has taken the container image as this, and it says it's in the running state. Go, and how do you access it? Sometimes this takes some time. Oh, some problems. There are two critical errors. The health check. Okay. The no logs at the moment. Let's go back to my resources. And this is the one. App service. Moment of truth. Let's try and access the app. Could see if there are any application logs. Limited. False. There you go. So this is the address. This is the default domain where you can access the app, and you can see came here. And one additional thing to show you is this app requires your GitHub token as one of the secrets for it to search the GitHub link. So you may have to add an environment variable as a GitHub token. Why am I saying is if I go here, try to search, I will hit an error because it did not find a token. So you have to go to environment variable, add your GitHub token. This is the environment name. So I'll just bring this screen to my main screen, not to let my GitHub token out. So, okay, there you go. I protected my GitHub token. I'll bring the screen back. You have the GitHub token. Now I'll apply, confirm. Successfully updated. I will go back to the app service here in the overview. Just restart. Yes. And wait for it. See. So the app hasn't started yet. Give it some time. Probably log stream is not enabled. Just checking.
Sometimes you have to restart the app. I mean, technically, the moment you save the app at the app settings, it
Mhm.
should do it. Sometimes it doesn't work. It
Yeah,
needs
it
a
doesn't work.
restart. Yeah, it needs a restart.
Yeah, I did a restart, waiting for the app to come to a running state. I think it has opened. Yeah. So we have relaunched our web app, and let's search maybe Django. Here you go. Yeah, it pulled in the top 10 apps, GitHub repositories you can refer. So we have hosted our application. Say you come up with a wonderful AI application and you can host in the Azure as simple as this, as fast as this, and share it with your friends and colleagues to have a look at it. So the last topic in this session would be to look at the workflow, which is the GitHub Actions. There's one thing I would like to mention here is I'll not be able to run most of the commands with my screen shared because that will compromise my Azure credentials. So I have done these things prior to the session. So I'll walk you all through this set of documentation, and then I'll give you a demo on how I can create a pull request, which will trigger our app to reflect the changes that you have done to the code. All these things will happen just when you do a pull request creation. So what is GitHub Action? These GitHub Action is a suite of features in GitHub to automate your software development workflow right in your code repository that will help you collaborate and help your software development cycle to be automated. So the few terminologies like workflow, action, and jobs, if you learn about what these things are, that will help you better understand the CD YAML that is there in this repository. So I think, better I show here. So workflows are in a YAML file, and they are stored in the .github workflow directory. You can refer to the GitHub documentation. This is one-stop solution for all your GitHub Actions information. So let's go to the main folder and access the workflow. So there I have written one workflow for this to automate whatever we did, building an image, pushing it to container registry, and your app service pulling it. All these things can be automated using GitHub Actions. So the name of the workflow is simple GitHub search application continuous deployment. And the trigger for this workflow is the pull request or push to the main branch. And this has one job called build and deploy, which has the following steps. This runs on a Ubuntu latest runner, and the first step is to authenticate. GitHub Actions will authenticate to your Azure portal, and you will log in to your container registry, and then you will build and push the image. And to build and push the image, you use several credentials, and we'll get to that part in next few seconds. And the Docker build command and push command, make sure the app name that you give here is the image name that your app service is actually pulling from the container registry. So here I will leave this as PD SGS app that I have created prior to the session. If I were to deploy the new image that we uploaded or we pushed into the container registry, this will be DD app because that is the image name that we chose. So I leave it with this because I'll not be able to create another service principal credentials and show you how to add these secrets. So make sure these two lines are updated when you try out. And the next step in the job is to let your web app authenticate to your container registry so that it is able to pull those images. So the app name will be DDSGS as according to the demo session that we saw, but this one is referring to the previous app name that I have created before the session. And the last one is deploy to the Azure App Service. And here the app name needs an update. If you're trying on your own, make sure the image is also updated. So once you do all these things, you're good to go and trigger your workflow. So let's see the last part of your actions. This is the one. So authentication is an important aspect in Azure. So now that we're running the workflow and automating the deployment using the GitHub Actions, we have to let some way this GitHub Actions workflow can authenticate to the Azure. There are several ways one can establish this authentication. And OpenID Connect, this link, you can explore the link that I just opened now. OpenID Connect is the most recommended way. That may be tedious. I'm yet to explore that. The simplest would be to use the service principal. And for this demo, I will use the service principal. If you ask me what is service principal, in brief, it is just another identity that we create in Azure so that applications can authenticate to the hosted services that we just did on the Azure. So it's as simple as that. So we'll go, and what do we do is you can list the resources. This will list all the resource group that you have provisioned on the Azure. And if I run this, you can see.
Hear me?
Yeah, is that a problem, Swamy? Okay, let's get through the last few steps. And these are the two resources.
Oh, we are running short of time. We are done with 1 hour 31.
Oh,
Oh, I
I'm
think we
almost
can
done. Yeah,
continue in the next episode where you can.
there you go. Okay, so we leave it at this time. We will leave everything at this stage and we'll continue in the next session. Thank you all.